Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to solve a Leetcode question number 20. Valid parenthesis. Given a string S containing just a characters, see here, these are the characters S contains. What are the characters? Just a parenthesis, then curly bracket, then square bracket, open close. Okay. Determine if the input string is valid. Okay. An input string is valid if open bracket must be closed by the same type of bracket. Okay, open brackets must be closed in a correct order. Every closed bracket has a corresponding open bracket of same type, so it should be in before, right? Okay, let us see the examples so that it will be more clear. See here, let me take this example. Here is one opening and here is one closing. So whether it is a valid parenthesis, yes, right? Yes, it is a valid parenthesis because we have opened here, we have closed in the correct order and right place and right bracket. Yes. Okay, let us take this example. Open bracket and then close bracket. Okay, this is balanced. Now again, open bracket, close bracket, so this is also balanced. Now open bracket, close bracket, this is also balanced, so this is also true, right? Now take this open bracket but close bracket, these are not same type. This is another type, this is another type, so it is false. Fine. Let us see some more example to clarify it. Whether it is a valid, no, it is not valid because there is a close bracket and there is an open bracket, but there is no order. Close bracket should be come this side so that it may be valid, but still it came this side, so it is not valid. Okay, let us take this. Whether this is valid, no, it is not valid. No. Whether this is valid, yes, it is valid. Whether this is valid, yes, it is valid. Whether this is valid, yes, it is valid. Now got some idea? Yes, yes. So let us see some observation. See here, if I split this example into two parts, right? Like, let me split here. I want to check whether this open bracket has a close bracket next to it. Also, this open bracket has a close bracket in next part of the string, okay. So here we are comparing the immediate next with the immediate previous. Okay, so can we use stack data structure? Because in stack it is always first in last out. Okay, so that the last occurrence will be taken first. That's why let's use this stack approach. Okay, let me draw a stack. Okay, let us take an example. Let us take this example itself. This example. Okay, first, it is what? Open curly bracket. Whether stack has any element? No. Just put it. Just put it. Okay. Now again, what is this square bracket? Okay. Okay. Whether stack has any element? Yes. Yes. But it is square bracket, right? It is square bracket. It won't have any validation. Just put it. Just put it. Okay. Now a close bracket. Close bracket. So we want to check. We want to check whether there is any element in this stack. Yes, there is an element in this stack. So what is the top element? It is open bracket. Now it is close bracket. So we can say recently a element occurred is a open bracket. So now it is close bracket. So it is valid, right? It is valid. So I want to do a pop off method. Okay, so that this open square bracket will be popped out. Okay. Now take this open parenthesis. If it is open, just push it. Just push it. We don't want any reason. Okay. Now take this. It is a closed parenthesis. So we want to check whether the top element is a open parenthesis and also the stack is not empty. Okay. So check here. Yes. Yes. It is what? It is open parenthesis. So it should be popped out. Right. Right. Now again, come to here. It is what? Closed curly bracket. So we want to check the stack. So what is the stack top? Stack top is open curly bracket, curly braces, right? So just pop it. That's all. That's all. Now see here. There is any element left over? No. There is no element left over. So we can say true. It is a valid string. Yes. Okay. Let us see some more example so that it will be more clear. Let us take example like open curly bracket, then a open parenthesis, then a close parenthesis. Whether it is valid? No, it is not valid. So you should return what? False. Let us see this example. Okay. Let me try a stack. Now, what is the first element? It is open curly bracket. Just put it. Just put it. Don't worry. Just put it. Okay. What is second element? It is what? Open parenthesis. If it is open, don't worry. Just put it. Now, what is the third element? Third element is close parenthesis. So you want to check whether the top element is what? Open parenthesis. Same type. Yes. So we are checking whether this is a same type. Whether it's a same type. Yes. Yes. This and this are same type. But this is closed and this is opened. So just pop it out. Just pop it out. We have any elements left out? No, there is no element. So I can say that's the end of this string, but we have one element in this tag. So I can say it is not in balance, not in balance. So in this case, we want to return what? We want to return false. Do you understand now? Yes. If stack is not empty after doing all this process, then I can say it is not a valid parenthesis, right? Now let us take another example, okay? Let us take another example like close parenthesis and then open parenthesis, okay? Let me take a stack here. Now tell me it is close parenthesis, right? It is close parenthesis. So we want to check whether stack is not empty and also the stack should contains what? A open parenthesis at the top, right? Right? But stack is empty, right? Stack is empty. So we don't want to search anything. We directly return what? False. That's it. Can you understand now? Can you understand now? Okay, let us see another example so that it will be more clear. See here, let us take open parenthesis and then curly bracket, then a close parenthesis. Okay. Now, what is a stack? Stack is like this. Now, what is the first character? It is what? Open parenthesis. Just put it. Now, second character, open curly bracket. Put it. Now, third is closed parenthesis. So, what should I do? I should do whether stack is not empty. Yes, stack is not empty. Okay, perfect. Whether stack top is open parenthesis. No, no. So should we check? Should we check? No, no way. Just return false. Just return false. Can you understand now? Can you understand now? What are the conditions we are checking? First of all, if it is open parenthesis, if it is open type, any open type, then we should what? Push into the stack, right? If it is closed, we have two. First thing, whether a stack is empty or if stack is not empty. Okay, which means if we have stack, then what should we do? If we have stack, what should we do? We should check for whether the top is same type. Is same type. Yes, yes. If it is true, then proceed. Then proceed. Yes. If it is false, then return false. So this is the first observation, right? If there is no stack, don't worry, directly return false. Directly return false. So after completing this all process, what is the last step? We want to check whether the stack is not empty. Whether stack is empty, whether stack is empty. If it is true, then return true. Yes, if it is false, then return false. Can you understand now? Yes, we are checking whether stack is empty. If it is empty, we want to return true. Else we want to return false. Because if, take for example, this is my stack, this is my string, then we will get a stack of length 1 which contains the open parenthesis, right? So you want to return what? You want to return false in that time. Can you understand now? Yes, yes. Okay, this is my first approach. Okay, fine. Now, what is my second approach? How can I approach this problem in any other different way? Okay, if we know, we can also do it in two-pointer approach. Two-pointer approach, but two-pointer approach can be done in only languages such as C++, Java, etc., in which we can modify our string. Modify our string. Whichever language where we can modify our string, we can use two-pointer approach. We cannot use in Python. Okay, we don't want any stack. We just take that input string and change in it, and we can tell that whether it is valid or not. Okay, but how can we tell it? Okay, let us see an example. So let me take open parenthesis, open curly bracket, close curly bracket, open square bracket, close square bracket, and close parenthesis. Okay. Now, okay, just see this example. Okay. Now, first of all, what is the type of this bracket? It is what? Open. It is what? Open. So it is valid, right? If it is open, we don't want to check anything, right? So just move on. But when we are moving on, we want to replace this r plus 1 with I. With I. Why? Because I will say in future, just come up with me. Just update my r pointer, okay? Just update my r pointer by 1. Here is my r pointer. Just update my I pointer to r pointer. That means this open parenthesis to this open parenthesis. 0 in this is replaced with the 0 in this, okay? Now make this as here. Initially, what is the value? It is 0 and minus 1. Now, what is the value? It is 1 and it is 0. Right? Now, again, what is the next type? It is also open. It is also open. Then what should I do? I should make this r pointer where? Here. This r pointer here. So, it will be 1. Now, I want to replace my r pointer with ith value. Right? What is ith value? It is 1. What is r pointer value? It is 1. So we will replace that itself. So this curly bracket is replaced itself. Okay. Now again move this I here. Now I is what? 2. Now check whether I is open or closed. It's closed. It is closed. So what should I do? I want to check whether this r pointer is previous to I, right? It's previous to I. So I want to check whether this r pointer is equal to this I. Yes, these two are same type. Equal to means these two are same type. Like it is open and it is closed. Okay, I'm checking it. Yes, right. It is open. It is closed. So I can say it is these two are valid. These two subproblems are valid, right? So what should I do? I should make this r pointer to move one step behind. So what is my r pointer now? My r pointer is 0 now. 0 now. Okay. And then, okay. Now take this I here. So I is 3. Got it. Now again. We are going to check whether this is an open parenthesis, right? We are going to check whether it's open or closed. It is open. Open means what should I do? We should make this r pointer move one step ahead. So r pointer is now facing here. Yes, and then replace it with what? The current I pointer. So can you understand now why I am doing this step? Don't worry. Just I am just doing a modification where we will take a upcoming next character and replace them in the previous character so that this two will be eliminated. Yes, and these data won't be lost. Fine. Now what is my r pointer? It is 1, and what is my I pointer will be updated to where? Here. Here is my I pointer. So it will be what? 4. Now come up with me. Just see what is the parenthesis here. It is what? It is closed parenthesis. So here is a square bracket, open square bracket, which means this resemblance, right? Now it is a closed square bracket. So what should we do? We should make this r here pointing to 0. Minus, right? Just minus 1. Now again take this I, bring here. So what is my I? Now 5. Again, whether it is a open or closed, it is closed. And whether it is same type, yes, it is also closed and it is also opened, and they two are same type. Yes, this r pointer and I pointer are pointing to same type where r pointer is opening and I pointer is closing. Okay, then what should I do? I should make this r pointer shift to -1. So my r pointer is where? -1. Now I pointer is shifted to where? 6. Here. So the loop gets terminated because there is no string left. There's no characters left. So where is my r pointer? It is at -1. So I can say it is a valid string, right? Why? Because we have went to so far and we have searched and modified every elements. After modifying every elements had a opening and closing perfect. That's why what? -1 is the answer for R. So that we will return what? True. Fine. Okay. Then what will be the case for this? It will make sense for this approach. Let us consider this approach for this example. Just observe. First of all, what is this? First of all, initially R will be where? -1. R will be at -1 and I will be at 0. Now listen carefully. I is finding the closed parenthesis. And we are checking whether R is greater than or equal to 0. Because if it is so, we can check, right? We How we can check for minus one, right? So that I can say it is not a valid parenthesis. Why? Because this r is at -1 and this I is at where somewhere at a point. But how can I put this? How can I find a open parenthesis beyond 0? That means -1, -2, -3. There is no index like this, right? So that we will return what? False. So this is the important case, we have to note it. Okay, fine. If you don't know about this, still you don't know about this, just I give you an example so that you can rerun it with this approach and you know how it is working. Okay, let me take this example. Open parenthesis, close parenthesis, and then close parenthesis, close. Yes, take this example and follow the same approach I have told here. You will find this, okay, and you will return this false. Fine. Okay, let me talk about the time complexity. What is the time complexity for this approach? I can say time complexity is O of n. What is the space complexity? I can say it is O of 1. Why we are saying it is O of n? Because we are just traversing only one time each and every characters in the string, and also we are just modifying this string itself, right? We didn't went any other strings, or we didn't went another looping, right? So it is what? O of n. What is the above mentioned approach time complexity? What is this time complexity? I can say the time complexity for this approach is also O of n, because we are just traversing to entire array and then we are just modifying this stack only. Yes, so it is O of n. And what is space complexity? It is also O of n, because we are using what? Auxiliary stack space. Fine. Now, the important note in this problem is, what is a common mistake? Common mistake. I can say the most common mistake that everyone do is they just count the close parenthesis. Okay, and then they will count whether there is a open parenthesis of same count. Sorry, open parenthesis. Now they will check whether these two are equal. If it is equal, then return true. If it is not equal, return false. So this is the major mistake everyone do. Okay, so don't do this mistake, because if we have like this, it will follow this condition, but still it doesn't work. Okay, so don't do this method. Do the stack method, or just observe this method, the second method. What is this method states? Initially we will implement the stack, right? We will implement the stack, right? Instead of implementing the stack, we are using the string as my stack. That's it. It is not so much difficulty. It's simple. We just implement stack, right? To do this problem, we implement a stack, or we can use inbuilt stack. Instead of implementing the stack, we can use the string as our stack. Because see here, initially stack will be where? -1, pointing the top will be -1, and we are checking whether there is any element and we are modifying. Okay, just correlate with them. Okay, fine. Now let's see the code now. First we can see the stack code so that it will be more clear. Let me go to the stack code. In Python we cannot do that second approach. Okay, we only can do this approach. See here, stack is equal to empty list, and for I in s, then if I is equal to any opening, then stack dot append up. Fine. Else then I want to check whether a stack is empty. Instead of doing this, we can also do like not stack. Same. Okay, if it is so, then return false. Right. Else if it is not so, then we want to take the top of the stack and check whether the top, any one condition of this is wrong, right? Like if the I is closing of one type and the top is opening of other type. If it is so, then we want to return what? False. Okay, otherwise if len of stack is equal to 0, at last after processing this entire process, if it is equal to 0, then return true. If it is not so, return false. Instead of this, you can also use like this. It automatically returns, right? That's it. All right, let me submit the code. Yes, it is submitted successfully. Now let us go for the C++ code. See here, initially I is -1. There I have used I and R, right? Here instead of I am using CH. Instead of R, I am using I. That's it, okay? Now, auto, Amazon, CH, colon S, okay? Now, CH is equal to any openings. Then I have to do what? S of plus I is equal to CH. Just I am moving my pointer one step ahead and just carrying them and modifying this value, right? Else, if I is greater than or equal to 0 and any one of this condition is satisfied, that is each and every opening has a closing of same type, yes, then I have to do what? I minus minus, because it is valid. So we want to go backward and modify them. We, instead of taking off them, we just go back and taking the next element and modifying them. That's it, okay? Else I will return what? False. At last I will return whether I is equal to -1. If it is so, what it means? It means every brackets is satisfied. Yes, so we can say what? It's a valid parameters. Let me submit it. Yes, it is submitted successfully. So this is all the two approaches for this problem. Thank you.